In the previous video, we stated the proof for the Pythagorean theorem, and we said it was a squared plus b squared equals c squared. The Pythagorean theorem in words is right here. So Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the square of the other two sides. So there's some fancy words which we didn't say in the proof, but essentially you have a triangle here. Now specifically, you don't have any ordinary triangle, you have a right triangle. So if you do not have a right triangle, you cannot apply the Pythagorean theorem. Because if you look back at the proof, the diagram, all the triangles were right triangles. So there was always a 90-degree angle. So we have the height and the base. So we can say A is the height of the triangle and B is the base of the triangle. And this side here, C, the longest side of the right triangle, is the hypotenuse. So A squared, the height squared plus the base squared, is equal to the hypotenuse squared. The height and the base, we also have another term to call them. We call them the legs of the right triangle. So we have two legs of the right triangle, and the longest side is hypotenuse. And if you have trouble identifying which side is hypotenuse, you should always look at where the right angle is, because the hypotenuse is directly opposite. It's facing the right angle. But if you forget that, just try your very best and identify which side is the longest side. Okay, so let's start using the Pythagorean theorem. So we have a right triangle here, and it's asking us to solve for the missing side. Okay, so they're asking us to solve for this side length, which they've labeled as C. So guess what? C is the hypotenuse of the right triangle. So you can write down the formula. A squared plus b squared equals c squared. So the two legs have a length of 12 units and 15 units. Does it matter whether you call A or let A be 12 or A be 15? And the answer is no. The legs are interchangeable. So I'm going to let A equal 12 and B equal 15. And my goal is to solve for C, the hypotenuse of the right triangle. Okay, 12 squared, you can punch this in your calculator, 144. 15 squared, you can punch this in your calculator, 225. Okay, let's add them together. So that's going to be 369. Okay, so I really don't want to know what c squared is. I'm interested in solving for c itself. So how do I undo the operation of squaring? So I'm going to square root, because if I square root both sides of my equation, I can tell you exactly what c is equal to. So let's punch out in our calculator. So, okay, and I'm going to round it to one decimal place. So the square root, 309. Approximately 19.2, let's say. So C is about 19.2 units. This is the missing side. So approximately 19.2 units. Okay, so we don't know if it's centimeters or meters, but we're going to say units because we don't know what the units are. Okay, for B, you know what? I see a right triangle and I'm given two sides. So immediately I'm thinking, hey, let's use the Pythagorean theorem. But be careful here. This time you're not solving for the hypotenuse. This time you're solving for the length of one of the legs of the right triangle. So be very careful. Okay, so this is going to be a squared plus b squared equals c squared. We'll start off by writing our Pythagorean theorem. Then I don't know what a is. This is our leg, okay? And then the other leg is 6. And c, our longest side, is 8. Okay, 6 squared is 36, 8 squared is 64. Okay, if my goal is to solve for a, how about we start off by isolating a squared? So what we're going to do is we're going to subtract both sides by 36. Okay, 64 minus 36, 28. And now, just like last time, I don't really want to know what a squared is. I want to know what a is. So I'm going to square root both sides. And if you do the math, a is approximately, let's take a look, 5.3. So therefore, the missing side is approximately 5.3 units. Okay. All right. Ooh, we have a nice little word problem here. So let's take a look. How high up on the wall will a 20-foot ladder touch if the foot of the ladder is placed 5 feet from the wall? You know what? I have a beautiful diagram here, but you know what? There's a lot of excess information. All I want is the right triangle. So I'm going to redraw the diagram. You don't have to, but this is what I'm going to do. I'm going to redraw the diagram. Okay, and of course we're going to assume that this wall is built perfectly. It's not slanted. So the ladder itself is 20 feet. The base of the ladder, the foot of the ladder, is 5 meters from the wall, or 5 feet. So what is the height? Let's call this h. So we should ask ourselves, we're definitely going to use the Pythagorean theorem because I see a right triangle, I have 2 of the 3 sides. The question is, should I use, or am I trying to solve for the leg of the right triangle, or am I trying to solve for the hypotenuse of the right triangle? So hopefully you're going to say, I'm trying to solve for the leg of the right triangle. So if that's the case, you're going to write h squared plus 5 squared, because h and 5 are the lengths of the legs of the right triangle. And the length of the hypotenuse is 20, so it's h squared plus 5 squared equals 20 squared. So now, let's simplify this. 25 squared is 5 times 5, 25. 20 squared, you could punch in your calculator. 20 times 20 is 400. I want to solve for h, so let's solve for h squared first by subtracting both sides by 25. So h squared is 375. I don't want h squared, I want h square root. Oops, square root 375, about 19.4. So therefore, the ladder is approximately 19.4 feet high up on the wall. All right, let's try one more question. Let's use the Pythagorean theorem. So I have a rug here. Let's take a find the area of the rectangular rug if the width is 12 feet and the diagonal measures 20 feet. So if the width is 12, it would really help if I knew the length of this rectangle, because the area of a rectangle is length times width. We're going to talk about area in the next lesson, but the area of a rectangle is length times width. So 12 times something would give me the area. What is length? Well, guess what? If you split the rectangle using the diagonal, you've basically chopped your rectangle into 2 right triangles. So once again, not that there's anything wrong with the diagram, I'm going to redraw it. I'm going to draw the right triangle. So this is 12 feet, and this is L, and this is 20 feet. So guess what? Am I solving for the hypotenuse or am I solving for the leg here? Hopefully you're going to say the leg of the right triangle. So L squared plus 12 squared equals 20 squared. Simplify a little. Oops. Solve for L squared. Inverse operation. Subtract both sides by 144. and then I'm going to square root. I'm going to square root 256. Oh, that's a beautiful number. 16 feet is the length of the rug. So now that I have the length, guess what? The area, because be careful, the goal of the question is not to solve for the length of the rug, it's to solve for the area of the rug. So length times width. So 16 times 12 is the answer. Therefore, the area of the rug is 192, be careful, not feet, square feet. Okay, 192 square feet. All right, so this is a nice sheet to practice your Pythagorean theorem. So we had some questions that just involved triangles without any context, and then we did some word problems where you can see right triangles in everyday life. There are many more examples of right triangles, but here are just two examples. So you got the ladder one and the rug.